Next, we explore sine and cosine curves for angles from 0 to 90 degrees. Our goal will be to convince you that really there's only one curve. We can pick either, but let's pick the sine curve. The second curve, cosine curve, can be related to the sine curve using three different relations. We will begin with the most interesting one. The race is over, and cleaning up after the race takes a long time. The city sends two trucks. The first truck will go from M to Q. The second truck will go from M to P. The drivers need regular breaks after cleaning 15 degrees of the quadrant and will call each other. The first break is when truck 1 has moved 15 degrees counterclockwise from 45 to 60 degrees, and truck 2 has moved 15 degrees clockwise from 45 to 30 degrees. The second break is when truck 1 has moved 30 degrees counterclockwise from 45 to 75 degrees, and truck 2 has moved 30 degrees clockwise from 45 to 15 degrees. The third break is when cleanup is over. Truck 2 has reached P and truck 1 has reached Q. Truck 1's coordinates are plotted in the first graph to the right. The x-axis is the angle from the 45-degree line. This is not the angle subtended at the center, but it is the angle from the 45-degree line as the trucks move away. So that means when truck 2 reaches P, he would have moved 45 degrees. And when truck 1 reaches Q, he would have moved 45 degrees. And truck 2's positions are shown in the second graph. The yellow line represents the vertical coordinate of each of the trucks, and the blue line, the horizontal coordinate of each of the trucks. At the first break, truck driver 1 asked driver 2 what his location is, and driver 2 says, my horizontal coordinate is about 0.86 and vertical coordinate is exactly 0.5. Driver 1 says, that's strange. My horizontal coordinate is exactly 0.5 and vertical coordinate is about 0.86. Did you notice anything about their coordinates? Is that a coincidence? Let's observe what happens at the next stop. At the second break, driver 2 asks driver 1 what his location is. Driver 1 says, my horizontal coordinate is about 0.96 and vertical coordinate is about 0.25. Driver 2 says, that's strange. My horizontal coordinate is about 0.25 and vertical coordinate is about 0.96. Again, your vertical coordinate is my horizontal coordinate and my vertical coordinate is your horizontal coordinate. Is that also a coincidence? Let's observe what happens at the third and final stop. At the third break, driver 2 and driver 1 think they have discovered a pattern. Driver 1 says, I am now sure that my horizontal coordinate of 0 is your vertical coordinate. You are at P after all. Driver 2 says, I am sure too, and I think it was always the case since we started from M. Let's check the graphs to see if driver 2 is right. In both graphs, the horizontal coordinates are in blue, and in both graphs, the vertical coordinates are in yellow. The blue line in one graph does look like the yellow in the other. Let's overlay one on top of the other and see. It looks like the drivers are right. One's vertical coordinate has been the other's horizontal coordinates and vice versa. Why is this? Because sine of 45 plus theta equals cos of 45 minus theta.